Hi, Algebra 2 Honor students. Today is Unit 14, Day 5. Today we're going to focus on translations to get started, but then really by the end of the lesson, putting all of the pieces together, being able to take a look at a sine or a cosine graph and apply many transformations to it to be able to sketch one cycle of the graph. So we start to talk about that concept of sketching one cycle yesterday. So hopefully we're starting to get in the mindset of what information is required to be able to sketch one cycle of the graph. Take a look at this example right at the top. So based on the transformations that I'm hoping you learned in the second graphing calculator lab, if I have y equals sine of x minus pi and then plus 6 afterwards, we want to think about, well, what transformations are occurring to the graph of sine to produce this graph? And then let's sketch one cycle of it. So as compared to y equals sine x, there's really two things. We're moving to the right pi and then we're moving up 6. Right? So according to the horizontal translations, we know it's the opposite direction of the sine on the inside. But then we do keep the sign on the outside and we move up 6 from there. So go ahead and see if you can sketch one cycle of that graph. Behind my very fancy yellow Post-it notes, I have what the one cycle should look like. But sketch one cycle of the graph based on those two transformations, that we're moving it to the right pi and then we're moving it up 6. If you want to hit pause and then go ahead and check in with me here. We'll go ahead and take a look. Let's see if I can do a fancy reveal. And maybe you got a graph that looks something like this. Okay, so what we have is that typically the sine graph wraps around the x-axis, but when you move the whole thing up 6, I drew that dotted line at y equals 6 to show you, hey, now your sine curve is going to wrap around that line y equals 6. So that's kind of important to pay attention to. And then I certainly move the graph to the right pi. So when I do that, if I want to sketch one cycle, and thinking about where the graph ends, the graph's going to end at 3 pi now. So you can see some of the labels that I have on the x-axis, pi, 2 pi. This would be, I should probably label it, why not? But this would be 3 pi all the way down at the very end. Okay. So that line y equals 6 is something that we'll come to call in this unit. I like to call it the wrap line because it's literally the line that sine wraps around, or the midline. Now, the midline is something that maybe you would see more used in like Regents exam language. So as long as you're comfortable with me interchanging those two words, the wrap line and the midline, they mean the same thing. It's basically accounting for where the vertical shift takes place. Okay. So once we've sketched that function, we're now ready to put all the pieces together in a recap from the second graphing calculator lab. We're now looking at functions for sine and cos in this form, y equals plus or minus a, and then we have sine and cos as our parent functions. B is the frequency that we've seen before, times x minus c plus d, putting all of the pieces together. There's going to be a lot of general information that I give you right now. I hope that it makes sense when we apply it to specific cases, but I would like you to at least have in your notes some of the good general information here. And of course, if I go too quickly, just hit pause along the way. Here's some good, really, definitions from those equations at the top. The amplitude is the absolute value of A. Remember, amplitude is never negative. If there's a negative out front, we know what happens. The frequency is this value B on the inside. It would be the coefficient of X. Notice how it's in a factored form right now. That will be important later on. Period is 2 pi over B. That's really important if I want to sketch one cycle of the graph. And then the fancy word we give for a horizontal translation is called a phase shift when we're talking about it in terms of sine and cosine graphs. And then the value of D is the vertical shift. So that would be the up or down piece. So hopefully that kind of all makes sense based on what we now know about all of the transformations put together. Today we're going to talk about making a complete sketch with all of these numbers filled in here. We're going to pick a value for, in some cases, A, B, C, and D, and make a sketch of one cycle. Well, first things first, you have to know what all the parents look like. It's important to know if I'm going to make one cycle in the end, what sine, cosine, and those reflected versions look like. So I typically write that down, even though it's going to seem repetitive. It just helps me to visualize in the end what my graph should wind up looking like. All right, in terms of the amplitude, that's going to be something we identify and we list. And if there's a negative out front, of course, you want to flip it over the x-axis. The amplitude is always, in fact, a positive number, though. Okay, so amplitude is something we'll list when we go to make a complete sketch. Frequency and period. Remember, the period is the time it takes to complete one cycle. And if that's what I'm sketching is one cycle, the period will be really important for us to identify. And it's based on the frequency, right? It's 2 pi over b, where b is the frequency. That's something we've actually done for a few days now, so hopefully that's a concept that we're pretty comfortable with. All right, number 4, other things that we want to identify in order to make a complete sketch are the phase shift and vertical shift. That's what PS stands for. So the phase shift is that left-right shift. Vertical shift, of course, would be the up or down piece of things. The wrap line is the line y equals d, because wherever that vertical shift is, the plus d at the end there, if it moves the graph up or down, that's going to be the line that your function wraps around. So it might look something like this for normal sine x. It could look like this for cosine of x. And keep in mind, it doesn't have to be a vertical shift up. It could be down, and the wrap line, of course, could be below the x-axis there as well. Okay? So all important things that we want to think about when creating a sketch of one cycle. And that's not all. I have more things that we're going to think about. Oh man, how could there be any more? Okay. Something that I'll be asking you to identify is the range of the graph. Well, to get the range of the graph, the set of the y values that we sketch over, you're going to start that the parent function is always going from -1 to 1. Sine and cos as a parent have this range. There are 2 things that affect the y values. The amplitude is a vertical stretch, where you multiply both ends by that vertical dilation factor. And then the vertical shift gets added to both ends as well. So the vertical shift part of d, I know this is a pretty generalized way of thinking of it. We'll apply it to specific cases, but you're going to multiply by the amplitude and then add on the vertical shift. It has to happen in that order, by the way. You got to follow PEMDAS there. So multiply by amplitude, add on the vertical shift. That's the new range of values. It's important to decide that in advance so we know how to set up the values on the y-axis. All right, the start, middle, and end points. Here's where things start to get maybe a little bit messier looking. But we want to decide, where am I starting if I'm only sketching one cycle? And then it would be nice to also know where we end. So the start for sine and cos are a little bit different, but they are based on the phase shift. So however far you shift to the left or the right, the value of c in the equation, that's the starting location. The y value for the starting location is on the wrap line for sine, but it's amplitude above the wrap line. It's at the highest point in the range for cosine. And that should make sense if you look back at the general sine and cosine graphs. Cosine doesn't start on its wrap line. It starts at the highest point in the range, which is a above the wrap line. So that's all we got going on for the start points there. All right, here's where things start to maybe get a little weird looking, but I hope this makes sense to you. Where does the graph end? What does 2 pi over b represent that I'm adding on to both the sine and cosine start x values? That's adding on one period. So you're going to add on the period to the start value, and that's going to get you where the graph's going to end. Notice how the y values stay the same when you have the start and end points there. For the midpoint, I'm just going to have you think average, and we'll talk about that, I think, in the context of a specific example that we get to. But we will list where a midpoint is and use that as a point that we can plot. Okay. Once you have all of that information accounted for, which sounds like a lot, but we're going to be able to make some sense of it, I promise. Then you're going to plot 5 points in sketch. The start, middle, and end points. And then we know where the in-between points should go, depending on if it's sine or if it's cosine. We're going to make that all happen. All right. If you have all that written down, I know it's a lot of info, so thanks for sticking with me through that. Let's go ahead and take a look at our first example that we're going to sketch. All right, so the first example for our sketches today will be make one complete cycle of y equals 2 cosine of x minus pi over 4 plus 1. We're going to sketch one complete cycle of this graph. So really quickly, off to the side, I want you to, as a reminder to yourself, sketch what the parent function looks like. If it's normal cos and there's no negation out front, meaning there's no reflection over the x-axis, we know in the end, we're going to see a graph that looks something like this. Now, it's going to be stretched and moved and shifted and up and down and left and right, but just in the end, know that it's going to look just like this. Okay, let's identify some of the information that I had in that very lengthy list of things I'm expecting you to know. The amplitude is 2. The amplitude's the number out front, and that's a vertical stretch of the graph. The frequency is the coefficient of x, which right now is 1, which tells you that the period is 2 pi divided by 1, which is just 2 pi. So this is how long it takes to complete one cycle of my graph. Okay. Let's talk about the phase shift. So the phase shift is we're going to go to the, if it's minus pi over 4, that's going to bring everything to the right pi over 4. And the vertical shift with the +1 at the end is going to move everything up 1 unit. So if you're pretty good to identify all of that information, we're really starting to build a case for making a complete sketch of one cycle of the graph here. All right, let's talk about next the range. So how do we find the range in general, the lowest point to the highest point? Well, you're going to start with -1 to 1 always. And then you're going to multiply by the amplitude. So the amplitude is 2. That's going to stretch the graph vertically. Now we're from -2 to 2. And then the last piece is that if there's a vertical shift, we add on the vertical shift. So the vertical shift is +1. So if I add 1 to both ends of the range currently, that's going to bring us to -1 to 3. This is the final range, the final set of y values that we'll see this graphed over. Okay, so we have that. Let's talk about the start point, the end point, the midpoint, and then once we have those points, we're ready to start graphing. All right, let's talk about the start. How do I know where this initial point is? It's not going to be in its normal location because we did a lot of transformations here. Well, the x value is how far to the right we shifted. So the start is at pi over 4. Now, what's the y value of the starting location? It's the highest point in the range, which is 3. So for cosine, just look at your parent function to help you. The highest point in the range is the start y value. Let's talk about where the graph is going to end, the coordinates of the point where it ends. Well, I know that it ends at the same height as where it started, so I know the y value here is 3. But how do I get this number right here? Well, if we're starting at pi over 4, how long does it take to complete one cycle? It takes 2 pi. So from that start, add on the period to figure out where we're going to end up. And you need a quick common denominator here, right? So if you were going to add these two fractions, this would be, if this is 4 down here, this turns into an 8. And 1 plus 8 is a total of 9 pi over 4. That's the coordinates where we're going to end. And finally, the last piece that I'm going to write down is the coordinates for the midpoint. The midpoint is this point right here. How do we get the x value for the midpoint? I said in the notes, think average. So what's the average between 1 and 9? You can always add them up and divide by 2, right? Midway in between 1 and 9 is 5. So that's going to be at 5 pi over 4. And then the y value, notice how that's the lowest point on the graph, right in the middle. Well, where's our lowest point? At a y value of -1. Okay, we finally have all of the information that we need to make a sketch, and it's based off of really those 3 key points. We have to also decide on a really sensible scale to use on the x and the y axes, okay? So I know that the lowest point is -1, so maybe I'll just make every one space on the x and y axis. Okay, so here's -1, here's +3. We now need to decide on a scale on the x-axis, and again, there's really no wrong answer other than the fact that if you choose too large of a scale, you might run out of space. To go from pi over 4 to 9 pi over 4, I'm going to choose a scale that every one space is another pi over 4. So here's 1 pi over 4, 2, 3, 4. That's 5 pi over 4. Let's label that because that's where the midpoint is. 6, 7, 8. We're ending at 9 pi over 4. So notice how that fit very nicely here. If I had made every 2 spaces pi over 4, could I have made it happen? Probably would have run out a little bit of space, but there's nothing wrong with that. Okay. Okay, the other thing I'm going to draw in here is where that wrap line is. So the vertical shift of +1, this is the new line that cosine is going to wrap around. Okay, typically cosine wraps around the x-axis, but with the vertical shift, it's now going to wrap around this line right here. Let's plot the first initial point at pi/4, 3. There's the starting point. If we jump all the way to the end, 9 pi/4, we're also at 3. And right in the middle at 5 pi/4, we're at a y value of -1. So we're going to have to go through that label there, but no big deal. What happens in between the start and the middle? At 3 pi/4, you're going to hit the wrap line. That's why I like to draw that in. And in between the middle and the end at 7 pi/4, you're going to hit the wrap line again. Those are the 5 points that I'm talking about to make an accurate sketch of the graph. And based on all of that, here is what one cycle of this equation looks like. It looks just like my parent. It looks like cosine x. But we certainly have some vertical dilations here to work with. We had a horizontal shift, a vertical shift. So all of these pieces put together, all of this information that we're determining helps me to make a complete and accurate sketch of just one cycle of the graph. Okay. I'm going to go a little bit faster through the next one now that we've done one together. But I think that hopefully we're on the right track of trying to put all these pieces together. I'm going to challenge us a little bit in this last one. Y-1 would equal 3 sine of 1/2 x plus pi/6. Okay, that's the function that we're going to sketch. There are two really important things to set up here in order to make a complete and accurate sketch. One of them being whatever the value of b is, which is the frequency, you have to factor out the value of b. Have to take that out as a GCF before we can decide what the horizontal shift is. The shift is not to the left pi/6. I'll tell you that right now. If you look back to actually the general form, notice how the b is factored out from the x minus c part there. We have to make that happen in our equation as well. The other thing I'm going to do is, I don't like y-1. Don't I want to add the 1 to this side? So I'm going to do two things in this very first step. I'm going to write this as y equals 3 sine of, when I take out the 1/2, the weird thing about taking a 1/2 from here is that you're really dividing it by a half, which is like multiplying it by 2. And I understand that that part might be a little bit weird, but we'll do more practice with it. Dividing 1/2 from this is like multiplying it by 2. 2 pi/6 is the same thing as pi/3. And oh, by the way, that -1, where does it disappear to? It's going to get added to this side. That +1 that we now have here is going to be the vertical shift. Let's see if we can start identifying some of the key information that we need for our sketch. So the amplitude for this graph is 3. The frequency is the 1/2 that I factored out, which tells me that the period is 4 pi. 2 pi divided by a half is 4 pi. That's how long it takes to complete one cycle, which is what I'm trying to do. The phase shift, notice how it's not to the left pi/6. It's actually to the left pi/3. And the vertical shift is going to move everything up 1, according to the +1 at the end. Okay, now that we have all that taken care of, the next thing I like to do is determine the range. The range, start with the parent, -1 to 1. Oh, by the way, what does this parent look like? Parent sine graph looks like this. Okay, so that's what we want it to look like in the end. All right, multiply by the amplitude. So multiply by 3. So now we're at -3 to 3. And then finally add on the vertical shifts. So if we move everything up 1, the final range is from -2 to 4. That's going to help me set out my y values in a second here. Okay, let's talk about the start point. Where is this graph going to start? Well, first and foremost, think about the phase shift. We're going to the left pi/3. So -pi/3 is the starting x value. Okay, the tricky thing about the y value is, where are all these y values? Start, middle, and end. They're all in the middle of the range. Here's the lowest point. Here's the highest point. They're actually on the wrap line. Where is the wrap line in this example? Whatever midway in between -2 and 4 is, that's where this y value is going to start. And that happens to be 1. Also happens to be the vertical shift. Okay. So the start, end, and middle are all going to be at a height of 1. because we're shifting the graph up 1 unit. Let's talk about the endpoint. We already said that it ends at also the same height where it starts, so at 1. How do I get the end? Take the start and then add on how long it takes to complete a cycle, which, oh, by the way, is 4 pi. In order to add these together, just like we did a moment ago up above, we had to get a common denominator. If I multiply the bottom by 3, I got to multiply the top by 3 as well. So now that's 12 pi over 3. 12 plus -1 is 11 pi over 3. And last but not least, we need the midpoint. The midpoint for sine, it's at the same exact height as the start and the end. So this is 1, 1, 1. That's pretty easy once you get the first y value. But midway in between -1 and 11, if you average those, you wind up getting 5. 5 pi over 3 there. Okay. With all those pieces that we're going to put together now to sketch this according to the range. Okay. Let's go ahead and hopefully I can fit this all in here. Okay. So we're going to go from -2 to 4. So we're going to go down to, that's the lowest point, up 2, 3, 4, that's the highest point. The wrap line, if you want to include that right away, is at y = 1. So this is the line that sine's going to wrap around. And I'm going to make every label on the x-axis pi over 3 this time. Because if I have to go all the way out to 11 pi over 3, I don't want to make it too large of a scale. This should work just fine, okay? So if this is -1 pi over 3, and I do have to go to the left, so it's important to label that, this would be +1 pi over 3. 2, 3, 4, here's 5 pi over 3, that's the middle. 6, 7, 8, 9, 10, 11. So 11 pi over 3 is right here. That's where we're ending. Okay. We know that sine starts, ends, and is in the middle, all on the wrap line, all at a height of 1. Okay. So we're so close to finishing one cycle. What's the last step? In between the start and the middle, what does sine do? Sine goes up to the highest point in the range, which is 4. So what's in between -1 and 5? It's going to be at 2 pi over 3. So midway in between here, you got to be at a height of 4. In between the middle and the end, you're going to be down at the lowest point of the range, which is -2. Right? So notice how this is 3 above the wrap line. That's 3 below the wrap line. That's because of the amplitude. And if you connect those 5 key points, that is one amazing looking cycle of the sine curve there. That is it. Okay. It is a lot of pieces to put together, which is why our next lesson is just going to be more practice with the same type of information. So I know this was a lot of pieces to put together, but I promise more practice is coming your way next time we're in class. Hopefully you're pretty good in terms of sketching at this point. Have a great rest of your day.